without further ado, let's go ahead and kick it off. For those of you who don't know me, my name is Nick Haase, one of the co-founders here at MaintainX. It's my privilege today to introduce you to my friend here, Terrence O'Hanlon. This guy is a reliability expert, if there ever was one. He has lived and breathed this space for a very long time, and I'm really excited to have him, to be able to share his wealth of knowledge with you all today and introduce you to some really exciting concepts that he's worked really hard to develop over the years that are not just theory. These are things that are being used by real companies that are seeing real benefits and success from them every day. So this isn't just some academic session. It's very much extremely practical, extremely actionable. And so hopefully there's some great pointers and things that you can learn and take back with you. And so without further ado, I'll hand it off and introduce it over to Terrence, and we'll kick this off.
Hey, Nick, thank you so much. It's so great to be here working with the MaintainX team and MaintainX team and to learn more about, what you're thinking. And your team, what we found is got a really fresh new ideas about the information of maintenance and managing the decision making. At the end of the day, it really comes down to decision making. Well, how do we make decisions in the world? We get all the information and we see what makes sense. And sometimes the information points us to an obvious decision. Without that information, we're never going to have an obvious decision in front of us. They're all going to be difficult decisions. So really admire the work you're doing up there on the technology front to bring maintenance into, the current century and match the kind of consumer technologies that we have out there and we're all so used to. I'm really honored to be here with the MaintainX audience also. So thank you. Really thrilled to see you all from around the world. I hope I get to meet you in person sometime soon. So thank you for that. I am going to not try to be, as Nick said, academic. I can talk about reliability from that perspective too, all day, every day. And I don't want to bore you. I want to give you something really to go and do at the end of the day. Let's see here. It's got a little bit of a new interface, so I'm new. Oh, they always tell me, hold on. They always tell me to open up and soften up the audience with a joke. So I'm going to tell you, almost every plant I go to has this scrapyard in the back. And in the scrapyard, they got compressors and gearboxes and things they can raid for spare parts. And three gentlemen were out looking for a spare part, and they found this brass bottle, and they rubbed it, and out popped a genie. And the genie said, I'm going to give you each one wish. There were three of you. Each of you gets a wish, anything that you want. And he looks at the maintenance supervisor and says, what do you want? And the maintenance supervisor says, oh, wow, I wasn't ready for this, but I want a yacht, a 250-foot yacht, South Pacific, caviar, champagne and beer in the fridge, my friends on deck dancing with some boom boxes going on, some really great music. Oh, yeah, and $1 million in cash in a briefcase on deck. Boom, and he disappears and he's down there. He turns to the maintenance planner and says, what about you? He said, wow, I don't know if I could do any better than that, except for I don't like the South Pacific. I want to be in the Caribbean. Poof, he's on his yacht in the Caribbean. The genie turns to the third guy and says, what is your wish? And he said, I want those guys back to work. He was the maintenance manager. He said, I want those guys back to work in 30 minutes. So just be careful what you ask for from genies out there. Reliability Web, we're here to make the world work for everyone with no one left behind. We want to make the people we serve safe and sustainable and successful. Our goal is 10,000 certified reliability leaders, and we'll tell you a little bit more about that as we go through this presentation. Let's see here. Sorry. Oops. I'm going to get this. I'm going to master this. I'm on my trackpad here to do this, so bear with me. So I do a bunch of things. I'm not going to bore you with all the things that I do. I work with ISO 55000 to write that asset management standard. I worked with a group of people that I respected a great deal to create this framework, the Uptime Elements framework that we're going to talk about. And it's really not a how-to framework. It may sound strange to you, but it's a why-to framework, and it's sort of a what-to framework. We really rely on you and your technical expertise as far as the how to go. So it's sort of a journey tool. And I know those of you who are directly involved in maintenance know it's a journey to go from where you are to where you want to be. And all kinds of things go into that journey. So that's what we're doing here. I got a chance to work with Tom Peters. If you don't know him, he's a great business book writer, ex-McKinsey consultant. This was his last professional presentation, and really miss him, but he taught us a lot. We've taken some reliability expertise from the marketplace, but we take expertise wherever we find it, and that's all gone into the work we do with Uptime Elements. Tom Peters also said to us, good managers have a bias for action. And I believe that's true. I hope you can take something from that. I wrote a book, 10 Rights of Asset Management with Ramesh Gulati. It's about ensuring, even when you're specifying an asset, designing an asset, procuring an asset, building an asset, and commissioning an asset, that you have reliability in mind. We don't want to wait until the keys are handed over and say, gee, what are we going to do about the asset operating the way that we want it to? So we're looking at those early asset lifecycle phases as really great opportunities to achieve reliability. We're talking about it in kind of a new way. It's time for something new when it comes to maintenance, because it's dangerous, it's high speed, it's a lot of pressure, it's a lot of high voltage. And I know the MaintainX team is aligned with me. We want you all to be safe. We don't think anybody should go to work in the morning and not come home at night, or not come home with their eye or their finger or whatever else they might have lost in a dangerous situation. So reactive maintenance is more dangerous than proactive maintenance. So it's one of the reasons we want to get you to look at being more proactive. So you kind of came to this webinar thinking one thing about reliability, and we really want you to leave thinking something different about reliability. It's important to us because we have a rule here at Reliability that how reliability occurs to you is exactly how reliability is going to be performed. That's the same with all your teammates as well. So we focus on changing how reliability occurs to you, and then that changes how you perform with reliability. Buckminster Fuller said, you never fight something you never change something by fighting the existing reality. To change something, you build a new model, and that makes the old model obsolete. This is our model. It's called Uptime Elements. You might notice it's got a certain resemblance to Mendelhoff's elements. It's colored in, nice, easy to follow and understand. It's in use at about 6,000 locations. It's got 4,000 certified practitioners. And I'm not going to spend a lot of time lecturing, but I do want to give you a little overview just to kind of set the table. It's based on practice research that we've been doing at reliabilityweb.com since 2002. In other words, just going into our audience and asking them, hey, what are you doing around preventive maintenance? What are you doing around reliability center maintenance? What are you doing around CMMS and EAM? If you notice, we did CMMS in 2005. We did CMMS in 2011. We did it in 2017. We did it again in 2021. So it's longitudinally connected. In other words, just connected over time. We've got these snapshots and we can kind of see where the market's moving. Now, one thing that's common in almost all the studies that we do is that, first off, you should be very proud that you've been chosen by your company to affect the arc of the future, to have a safe, reliable, and a successful operation. They've put you in a huge position of trust. But you might want to feel a little anxiety because the road to reliability is littered with failed programs. And it's not necessarily the fault of the people involved. It may not be the fault of the strategy. It may not be the fault of the technology. There's many things that can go right, and there's many things that can go wrong. And what we want to see is, look, if we're gonna go, for example, implement MaintainX, well, the boss is going to say, okay, how much is it? And you're going to say it's X. MaintainX, it's X, and then he's going to say, well, what's it going to do for us? And you're going to have to say Y. You're going to have to turn X into Y, which includes a return on investment for the money you're asking the boss to spend to get this new technology. Well, 18% of the time, it's a boom. It shows up on the financial statement. Your profits are up, costs are down, safety's up, environmental compliance is up. Everything's going the right direction. 82% of the time, that's not the case. You go and you get your low-hanging fruit, but there's missing opportunities there. And if we really want to promise the people who come to work in the morning that they're going to be in a safe environment, we got to do better than that. So our work is about taking that iceberg and flipping it upside down and not having so much unsuccess, having more success with the technology that we're using. The top challenges that our audience identified is that they're missing an asset management strategy. Nobody knows quite what the overall plan for assets is. Data quality tends to suffer. And a lot of that, I believe MaintainX is changing because they're making it easier for the person at the asset to actually put the information into the system. Other systems, the assets over there, you ever notice that? The assets over there. And you ever notice that the people are working over there? 50% of the audience at Reliability Web, 50% cannot get a work order on a telephone. I'm telephone, sorry, I'm revealing my age. They cannot get a work order on a mobile device. Let me say it that way. That's crazy. This is 2023. That's plumb crazy. You're not going to have good data quality if you're relying on the guy to go from a mile out that way back to the computer when somebody's calling him saying there's a pump broken a mile that way. You just don't get good information that way. Standardization. What do you call it? What's the catalog? What's the hierarchy? What's the numbering? What's the location system? What's the kind of work we're going to do to it? Planning and scheduling. We're still struggling with that planning and scheduling function. I'll give you a little spoiler alert. One reason why you struggle with the planning and scheduling alert is because you still have reactive. Yes, you did everything you needed to do to move to plan, but the reactive still sticks around. And we're going to talk about what we can do with that. Interoperability. Does your software work with other software? Can you purchase through it? Can you track hours through it? What else can you do? And what other systems can you interoperate with? I'm going to show you a stat on CMMS learning. The training, train your people, train them, no matter how simple it is. I know MaintainX is simple to use. You still have to train. You have to train your people on what you expect. And so those are the challenges that our audience is telling us that they're facing out there to have those safe, reliable. Here's a real disappointment. And this hasn't moved since 2005. Sometimes it goes to 13%, sometimes it's 14%. I'm funny. After I spend a couple $1 million on software, I kind of want it to be over in the excellent category, and I'm blocking that excellent category. There it is. Excellent category. Why not? Why shouldn't our software be excellent? Do you have software now that's excellent? I mean, I work with excellent software all the time. Why can't my CMMS be excellent? That 42% that said good, by the way, the more training they got. If they had 7 days training, they said good or excellent. If they had no days training, they said fair or poor. So there was a direct correlation between how much you train them to use that technology and the results that they did. And if you look, what's the number one source of training for CMMS? Johnny trains Jimmy, Jimmy trains Susie, Susie trains, and some of that is okay. I mean, some of that application, but you really need to train if you want to get your return on investment out of the technology. Now we're going to start in the middle and work our way. Oops, we're going to start in the middle. Sorry, I'm going backwards here. And we're going to start with what we call the work execution domain. That is all about efficiency. And why? Because we got a ton of people working in maintenance and we're using a ton of materials, spare parts and consumables. And the boss expects us to be efficient with that. So we have to have a PM, a preventive maintenance program. We have to plan and schedule that preventive maintenance program so we're not interrupting operations as much. We have to have all the right spare parts and consumables when we go to do maintenance work. And we use our CMMS as our accounting system. That's our business management system for our assets. And we have to treat it like your accounting department treats their accounting software. They don't say they got 50% of their assets in the accounting software. They have 100% of their assets in their accounting software. They don't say they track 70% of accounts payable. They track 100% of accounts payable. You have to hit 100% with what you're doing inside your business management system, which is hopefully MaintainX, if not soon to be. We also have what we call defect elimination and operator-driven reliability to help us with that work execution. We're going to talk about those as we go too. So almost every organization we go to has some form of this blue, has some form of the work execution, because work needs to be done and we need to do it. So we need a way to execute it. So almost every company we go to has some form of this. They may still be struggling a little bit with it, but they have that. Sometimes what they're missing is that reliability strategy, that reliability engineering for maintenance. And what we're talking about there is which assets are critical. There's sort of two views of that. Which one's critical for the delivery of my business? If that pump goes out, what happens? But the other way to look at it technically from a reliability standpoint is, what is this? If this asset fails, is it going to kill or hurt somebody? If this asset fails, is it going to cause an environmental incident? If this asset fails, is it going to interrupt production significantly? And if this asset fails, is it going to have such a huge maintenance cost on it that the boss is going to get involved? We need to have that view. Why do we need to know what's critical? I've got another breaking news story for you. You don't have time to do everything. You don't have the staff you need to do everything. You don't have the funding you need to do everything. And guess what? Even if you did, there's some things you shouldn't be doing. So that's what reliability engineering is doing. It's telling you what to do, but I think more importantly for maintenance people, it's telling you what not to do. In other words, don't take a perfectly good working asset and take it apart. My mom used to call me a destroyer when I was about 6 because I like to take apart the radio or the blender and see how everything worked. I wasn't very good at putting them back together, but I was excellent at doing the root cause analysis about what made them work. I could figure out what made them work at the time. So the other thing, by the way, that we do in the orange is we figure out what are the ways that the asset can fail. What are the failure mechanisms? What are the things that will cause a failure? And what are the modes? So mechanisms, modes, and causes of failure we're focused on. And there's a language around that needs to be adopted. We talk about the cooling tower water pump bearing seized due to lack of lubrication versus the pump broke. I mean, in CMMS systems, we see those words, the pump broke. And then we say, wow, okay. And then we go and look and it says the pump was fixed. That's almost useless for the reliability engineer. But when you have a part problem cause description, that's super useful for the reliability engineer. What was the failure mechanism? Great question. What is a failure mechanism? That's a great question too. Without a common language, common concepts cannot be shared. So you want everybody, not just the maintainers, to sort of have at least a basic language of reliability. Using common frameworks across the enterprise sets the language. So even if you disagree with MT and the uptime elements, you can calibrate your disagreement to that. That's fine. You've frozen. There's a real advantage to freezing a terminology set for your team. So you're not wondering what's going on. You're not wondering about the language. Now we have asset condition management. Well, you're hearing all about IoT. We're going to talk about that a little bit. But these are the sensors. So imagine I went to the doctor and I said to the doctor, I'm 64 years old. Oh, Terrence, 64. Yes, doctor. We must change your heart. What? Why do you have to change my heart? Well, because the average mean time between failure on hearts is 64 years. Well, but maybe my heart's different. I've eaten well. I exercise every day. I don't eat a lot of cholesterol. You sure, doctor? No, it says right here, mean time between failure, 64 years. Well, I would like to have some sensors on me first. And hopefully I've been going to the same doctor year after year after year. So he actually has a trend history on me, on my blood pressure, on my pulse, on any x-rays and things of that nature. We need sensors. We need vibration sensors, fluid analysis sensors, ultrasound sensors, infrared sensors, electrical current sensors to give us that early warning the way the doctor says, oh, Terry, I'm worried your blood pressure's up. Terry, I'm worried your pulse is low. Terry, I'm worried about, because they're censoring me and they're watching me over time, because most of the failures you're going to deal with on your complex assets are random. I'm going to stop there for a second. They're random. In other words, they don't fail on a nice, evenly. Some do, but not many, less than 20%. 80% of the world is random. Doesn't mean they don't wear out. Doesn't mean they don't break. It means that we need sensors to give us advance warning so we have time to plan, we have time to schedule, we have time to get the parts in, things of that nature. And that's why asset condition management is so important to the reliability mix. You know, what happens is, if we know the pattern, of wear out in the machine, and for some we do, for about 20% of your assets, you can figure out, okay, this goes every 2 years and then we got to rebuild it. We got to put new bearings in or something. You operate that asset as long as you can when it's in healthy condition, and then it's designed for rapid wear out. The bearing is designed to wear out before the shaft does. It's a softer surface than the shaft is. So what we're trying to do is have that replaceable item, just being able to get in and replace that, know when that is, and be able to schedule it and things of that nature. That's what the traditional time-directed, time-based maintenance looks like. But the problem is, about 80% of the time, that pattern doesn't apply. It's the first part of the pattern that applies. Look at it. It could fail on day 1. It could fail on day 100. It can fail on day 1000. It's the same likelihood of failure. So unless you're sensoring, unless you've got a vibration sensor on there, an ultrasound, an infrared, you're not going to get that early warning. If you don't take your blood pressure, you're not going to know your blood pressure is high. You have to take the blood pressure of your assets to know what's going on with them. And we use asset condition management for that. When we're doing reliability center maintenance, we can pick a time-directed task or a condition-directed task. Best practices shows that 35%. Now, just sit and think of your own maintenance program. 35% of the proactive activity should be condition-based because of that random. And then it should generate about 15% of your maintenance follow-up actions and tasks. I'm Swingali here. You're probably doing about 5% rather than 35 and 15. Now there's no excuse because we've got these IoT systems. We used to have to take actual instruments and go back to the machine and actually do the testing at the machine. Now we can put a wireless sensor with Wi-Fi or Zigbee or all kinds of connections on it, so the vibration data can come to me if I'm sitting on the beach in Maui. You know, it's fabulous. You know, we want to connect our assets and our systems and connect our people together. If you look here, there's sort of the bottom path and the top path where we're gonna connect. The source of the data is the pump and the motor. Now, maybe you've had to put vibration sensors on there, but there's already electrical current. There's other signals you can get even if you don't have the advanced vibration. We're connecting to those assets now. In other words, MaintainX to the asset. And we're going to bring it in and we're going to collect it and we're going to compare what the theoretical or the engineering measurements are, the model measurements, versus what's actually happening out in the real world. 24 hours a day, 7 days a week, not going to visit the machine once a month and touch it with a vibration meter. The vibration meter's on it all the time. And now artificial intelligence can kind of look at that and say, this is healthy. Don't worry, go fishing for the weekend. Or you ever notice the stuff breaks down Friday when you've got a fishing trip planned for the weekend? Or it tells you, no, there is an issue here, but it also then prescribes, you better handle this issue now. Or you've got some time to do this, or here's what the classification of the issue actually is. Get rid of that. So then we're going to jump all the way to the right side of the framework. We're going to talk about asset management. Now, a lot of times people use that interchangeably with maintenance, or it's my asset management software. I'm doing asset management. We have a distinction. We call that managing assets. That's stuff we're doing to the asset. Asset management for us is the managing system. Asset management for us are the decisions that you're making. It's decision-making around the life of the asset. Why? To get the corporate objectives achieved. So the corporation has goals. The corporation's chief executives expect us to aim the assets for the delivery of those objectives, not to the left of the objectives, not to the right of the objectives. So in other words, if we're trying to make more N95 masks off of our production line, we're not necessarily looking to save 10% to do it. So in other words, we would be focusing our asset management decisions on maximizing production, not reducing cost on maintenance. Might be the other way around. We might be making corn syrup, and whoever can make the corn syrup cheapest wins the marketplace. So there, it might be that asset management is aimed at bringing the maintenance cost down. It depends on the business context. So it's the decisions that we make. That's what asset management is, and they're very formal in nature. They follow these four big ideas. You have a purchasing department. Do they have an effect on reliability? Sure do. You have an HR department. Do they have an effect on reliability? Sure do. You have an engineering department. Do they have an effect on reliability? Sure do. You got an operations department. Do they have an effect on reliability? They all have separate objectives because they have specialties that management is asking them to achieve. But there's only one company. And there's only one set of top line objectives. So what management expects is that we're collaborating, but in reality, we're not collaborating all that much because everybody's busy, everybody's overworked, underpaid, overstaffed, understaffed, that kind of thing. So we try to align the objectives across the organization. And that's why in one way, Uptime Elements is actually more important for the non-maintenance people as it is for the maintenance people, because you can't just maintain your way to reliability. We need purchasing, we need engineering, we need operations. But the problem is they think we're from Mars the way that we talk. And so we need to find a way to speak human to them. And this Uptime Elements is sort of that bridge. We also need, what do we make decisions based on? Is it safety first? Is it reliability second? Is it value for money third? Is it organizational development fourth? What is our decision-making framework? How should all the team members rank the values that we have here at the company to make decisions? And then what tools are we using to inform risk? One reason why you want to keep such an accurate transactional data in MaintainX is that we need to be able to spot risk is coming up. Hey, when we buy these pumps, or when we operate these pumps at this level, or when we maintain these pumps this way, it decreases our risk or it increases our risk. We need to be able to see that. You will not see that if you do not put the information in the system to begin with. And then last, let's get out of this 12-month asset management cycle. Yes, we have budgets. Yes, budgets are a reality. But if the asset is a 20-year asset, let's have a 20-year asset plan.
Now, Terrence, this is fantastic, but a quick question for you here. I'm sure you got a lot of maintenance folks in this room, right? Reliability professionals nodding their head like, yes, preach. You're preaching the choir. What's your advice to say, hey, how do I get my leadership to care about this? How do I sell this to them? Because this is probably really resonating with what you're talking, what you've shared so far.
Yeah, and I think a lot of that, and with any role, whether it be the executive sponsor or the plant manager or the operations leader, you got to find a way to speak their language. For years I was frustrated wanting them to come and speak maintenance. Well, I've come to the realization, and Nick, you probably came to it much faster. You're a quicker study than I am, so I'm sure you already know it, is you can't go in talking mean time between failure to your CEO. They're just not going to follow it. Now, you can talk ROI, or you can talk cost, and you can talk things like that. So I think a lot of it's bogged down in language, to be honest with you. The boss doesn't know. So for us in maintenance, we feel like the boss should be 20 times smarter than we are. Well, maybe when it comes to interest-free bonds or bank financing, they are. But they are not smarter than you when it comes to the operation of the assets at the plant. That's you. You have a lot. You're 50 times smarter than they are. But your job isn't to go in and impress them with how smart you are about the machines. They got to run a business. So how do you talk to them about what you can do and how they can support you in best running their business? Sometimes it seems like we're at odds with management, or we're at odds with operations, that we even though we're in the same company, it seems like we're fighting with them all the time. And I think a lot of that is just misunderstanding. Morabad, I don't know if you know her, she works at Reliability Web, speaks 13 languages, very human-centered. it's just important for her that everybody be heard, everybody's perspective be recognized, and things of that nature. I think that brings a lot to the reliability game. In other words, can we bring some of that human-centered stuff into maintenance? Why not? Why can't we? Why does it work in all the other areas of the company and not in maintenance and reliability?
Fantastic. Yeah, that makes a lot of sense.
This is a totally boring flow diagram, but basically what it's really telling you is that these are the yellow boxes are the 7 requirements of ISO 55000. I know it's geeky. Just like ISO 9001, you might use that. You might use ISO 14001 already at your company. If you do, by the way, you're 70% of the way to ISO 55000, because it's the same 7 requirements in those management systems. So this is another way that you go back to Nick's question, you might interest your management, because they think sometimes wrongly, I'm not saying it's right, but they think you're a black hole in a money pit. They don't see anything good ever coming out of, let's call maintenance. They don't like that. They see that as a cost. But the reality is, if they didn't want that cost, they should have designed the equipment a little bit better. They should have done some things early in the asset life not to have that. We have to align with what they want. They're not going to align to what we want. We have to align to what they want. And so when the management starts to see you not just doing the technical things well, they see you doing the business things well and bringing the technology and support of the business, you will have their ear, you will have their eye, you will have their attention. The problem is sometimes maintenance can get disconnected from the business. Because again, we're understaffed, we're overburdened, we're underfunded, and it's just a tough position to be in. I love you. I want you to know that. I know Nick does too. That's why we work so hard. We don't want to see you in that uncomfortable position. We want you to be the rock stars of your company. And the problem is, when you do your work perfectly now, you disappear into the background, because nothing's blowing up, nothing's breaking down, nobody's going, gee, sure, good thing Ralph was here today when the pump went down. But if the pump doesn't go down, they're not thinking about Ralph. So we want them to think about you as a business resource. You're part of maintenance doesn't make what operations make, but maintenance makes the capacity of operations. And we have to find our value. It's right for us to know our value. It's okay for us to know our value. But we also have to start adopting more business. They ask us, how many of our assets are in our CMMS? 50%, 70%. Well, wait a second. I see an asset in here that we took out of service 3 years ago. Yeah, we haven't had time to get that out of here yet. See, that doesn't happen in the accounting department, because the accounting department has a managing system. And it's clear and it's transparent and they report it every month, where maintenance, not quite so. So start running your department like an accounting department. You'll start to get a lot of management love. This is just to show you we're able to take apart Uptime Elements and put it back together as ISO 55000. We can take it apart and put it together as a lean production system. We can take it apart and put it together as a Toyota production system. It's a very flexible system. I meant to say, when I showed you that original diagram too, there is no requirement that your team needs to have to meet Uptime Elements. Uptime Elements is required to meet your team where they are, with no movement from your team. In other words, their journey starts where they are. And Uptime Elements is perfect for that, because it doesn't matter where you want them to be if they're not there. So those are sort of 5, we call them knowledge domains, that are designed to work together. Some of them are management and business processes. Some of them are technicals. And we want them to work together to have the technical domains now aligned to the business process or the management domains. But we also need to do that across the entire asset lifecycle. We want to specify the asset right. How much does it cost to get rid of a failure mode in specification? It doesn't cost you anything. How much does it cost to design it right, to source it right, to build it right, to install and commission it right? Those 5 phases give you a lot of leverage for reliability. Once the keys are handed over, think about you driving the car off of the new dealer car lot. The first thing you're thinking as you're driving home isn't, how can I make the reliability better on my car? The car came with an inherent level of reliability. That's because of right 1, 2, 3, 4, and 5. Now they've given you the keys and you're about to go into right 6, operate it right. I had a 16-year-old son I let operate my car for a year, and let's just say he didn't operate it right. And I had some reliability work to do after that. Maintain it right, improve it, modify it right, decommission it right, and ultimately manage it right. This may seem like a lot of overwhelm to you. How could you possibly have a thread that goes all the way through all these different phases? That's what a technology like MaintainX does. As soon as you start to dream about an asset, you should think MaintainX and start putting the information in from the very, very beginning of that asset's life and not have any time period where that asset is not being managed. I worked with Crossrail in the UK, the biggest engineering in Europe for several years, building 41 miles of subway in London. They were managing 1 million assets before they were born. In other words, they had it in their CMMS system already. They had data definitions. They were really well prepared. So, just think about that. That is something really doable for you. This is a super geeky diagram. I'm not going to spend a lot of time on it. We call it the SDI-PF curve. You may know it as the P to F curve, where it says potential failure and failure over on the right-hand side. That is from Nolan and Heap's Reliability Centered Maintenance Report. And what that told us is if we use sensors, vibration sensors, ultrasound sensors, whatever kind of sensors, we could tell whether an asset needed maintenance when it came in for its overhaul or whether it didn't need maintenance for its overhaul. And what we wanted to do is plan and schedule that maintenance prior to it becoming a functional failure. So that was the idea of what became known as predictive maintenance. But the real sweet spot is, how about we don't ever let the defect happen to begin with? In other words, the reason why that bearing failed is because you put contaminated lubricant instead of clean lubricant in. So the bearing failed earlier. What if instead, from the time we install to the time of that potential failure is detected by a sensor, we try to extend that? If it was your car, wouldn't you like it to be from the time you drove off the lot, you never had to take it back to the dealer for an unplanned maintenance ever? That's possible with some cars. Now make it possible in your plant. So run that asset, install it well, balance it well, align it well, clean, dry, compatible lubricant. Instead of fighting all the time the end of the asset life, let's extend the beginning to the middle of the asset life before we're starting to fight defect problems. Of course, we need strategies to fight defects, but we also need strategies to extend smooth operational excellence. And that's what the idea is there. It meets the requirements of ISO 55000. It's asset management life cycle. In other words, we're looking at the asset through all the 10 rights: specify, design, procure, build, commission, and then operate, maintain, improve, and decommission. So that's the whole idea, is looking at the asset, not just once it's born, but you can do a lot before it's born to make sure the reliability is high. If you look at the red curved line that starts at specify and goes down, that's telling you that you have a lot of opportunity early in the asset life to improve the reliability. Oops, webinar chat. All right, I'll take that off. And that's where we've got a lot of opportunities at the beginning of the asset life. The only way to improve reliability after commissioning is either modify that asset, same as your car. You could modify the car. I doubt it's going to make it more reliable, probably make it a little less reliable, or improve the car, that kind of a thing. The other thing, and this should really get you sitting on the edge of your seat, safety follows the exact same pattern as reliability. In other words, you make safety back in the specification and the design. You don't make safety once it's operating and maintaining. You're achieving inherent safety at that point in time. Same thing with sustainability. They follow the same thing. So go to your boss and say, hey, we have to get involved in these capital projects. The maintenance team needs to be involved in the capital project. Yes, that costs us a little bit more. We may point out some problems that are going to cost you some more money on the design and things of that nature, but we're going to save money for the company across the entire life cycle. In fact, the research shows you can save up to 40% of the total cost of owning that asset if you if you design it, specify it, build it, commission it right. So it's worthwhile to do. And then again, pay attention to extending out this I to P interval. From the day you install it, a lot of people say to me, well, the worst day of the asset's life is the day of its commissioning. And then we get it better from there. Why should that be? Do I want the first day of my car's life to be the worst day of my car? I want that car working. I don't want anything happening to that car. The commissioning should be the best day of that asset's life, not the worst day of that asset's life. If you got people that tell you that, that means they don't know jack about getting that asset ready for reliability, for a long, reliable asset life. Let's make commissioning the best day of the asset's life. We're ready for everything. It's installed. It's balanced. It's well oiled. Everything's good on that thing. Tom Peters said to us, design is so critical, it should be on the agenda of every meeting in every single department. So we've always got reliability in mind for that. Now the last domain is leadership. We thought when we put this in, that would solve everything. Just do leadership and everything works. We didn't have the yellow on at that point in time. It turns out that leadership is a good foundation. We need a foundation of leadership. It's about creating the context for people as reliability leaders who work in a culture of reliability. That's where the performance gains come from. Of course, install new software, you're going to get performance gains. Put some new sensors in, you're going to get some performance gains. Those performance gains are amplified tremendously when you engage your people. Nick will tell you, one of the things that they really measure probably for customer success, adoption. Adoption, they know if they get a customer successfully adopting the technology, they're going to be a customer for life. Customers who don't adopt are going to have some struggles with it. That's because the performance comes from the people. Yeah, they got magnificent technology, easy to use, really powerful, fabulous. But they would own the world if that was all they had to do. They were already the winners. Ching, win. But the problem is they got to get people to use the technology. That's where the struggle comes in. And it ain't the technology that's the struggle. It's the people side of things. So, but it's really worthwhile to put some time and energy into your people. So look, if you're going to spend $1 million on software, go spend $1 million on developing your people at the same time. Because if you feel like the software was worth $1 million, developing your people is definitely worth $1 million. So have them ready for that new technology. You know, imagine every employee in the organization empowered and engaged to think and act like a leader. We say leadership creates the culture. Culture delivered the performance. So let's focus on leadership if we want to improve performance. That's what Buckminster Fuller called a trim tab. He asked, how can one person make a difference? And the metaphor of a trim tab is, you know, you try to push on the front of a ship while it's going across the ocean. You can't really turn the ship. You go to the back, there's a big rudder. But, you know, on a ship like the Queen Mary, which he was talking about, big rudder, very difficult to turn. You can use hydraulics to help you. But there's a little hinge device on the back of the rudder called a trim tab. You've seen it on like a landing gear on a flap on a landing gear on an airplane. It creates a low pressure flow. So it's just a little hinge device on the back of this huge rudder, and it creates a low pressure flow, and then it's easy to turn the rudder. There's about 100 trim tabs in Uptime Elements, and empowering even the lowest technician in your staff as a leader is a winning strategy. That's what we've seen. Yes, you have to master all the technical stuff on the left hand of the page, but the performance is going to come out of what you do on the right hand of the page. The performance comes from the people and culture at work. We work with a reliability leadership context that includes integrity, authenticity, responsibility, stand, and aim, working for an aim that's bigger than oneself. So when we put our reliability leadership, when you do the same work you're doing now, but you do it in the context of the 3D reliability leadership, we claim, and you can hold us to it, that if you follow this without anything new, you can improve your performance 100 to 500% just by following these simple rules. And we've seen it happen numerous times. So remember, we're going to have the asset management strategy to assure our management Don't worry, guys and gals, we're going to take your assets that you've invested millions and billions of dollars in, and we're going to achieve your organizational objective with them. That's what asset management is. Then we need reliability to say, okay, well, if we're going to achieve the objectives, we better make sure these assets can function like the asset owner wants us to. They need to be effective. And that's what the reliability piece brings to it. We need to be efficient. That's what the work execution piece brings to it. So we need to be efficient because we're spending a lot of money on labor and materials. But ultimately, we need to appreciate that the performance is going to come from the culture. So it's sort of like, which one? All of them. You have to do all of them. You can't just do one of them. It's a holistic approach. And it's one of the reasons why it's so difficult. Look, if it was just you and your toolbox and MaintainX, life would be easy. But that's not that. The problem is we got an operator who runs that machine that we're working on. We've got a boss who runs the plant. We've got a boss's boss who runs the company. And they need to see that we've got a holistic approach to taking care of their assets. So where do we want to go? Our target is right there in the center. An engaged, empowered, cross-functional culture of reliability, not just the maintainers trying to get to reliability. You know, you've seen that already. So if I asked you who was responsible for safety in your plant, you'd throw me out. Yeah, everybody. Terrence, why would you even ask a question like that? Of course you know everybody is. Who's responsible for reliability? Joe back there in maintenance is. That is not so. Everyone who's responsible for safety is responsible for reliability as well. And they, by the way, they go hand in hand with each other. But it's the exact same kind of context. Everybody is responsible. When you have an engaged, empowered workforce, it's not about making reliability happen. It's about letting reliability happen. So now you've got your technology. MaintainX is your Tesla. 0 to 70 in 2.1 seconds. Right? They got the slickest technology. It is awesome. It's mobile first already. You don't have to buy something extra to get it on your mobile device. It's simple to use. We use Uptime Elements as the asset strategy to put into maintenance. MaintainX already has a technology strategy, and it's excellent. Now we're supercharging that, just like the Tesla gets a supercharge from the electricity. We're supercharging that with the Uptime Elements. But at the end of the day, it's your people and it's your culture. That's what's going to provide the electricity that drives both MaintainX and Uptime Elements. So that's what the idea of that is. I hope you'll calm down. I know it's a terrible place, especially if you live in the north. Marco Island, Florida, December, sugar sand beaches, dolphins frolicking out at sunset and things of that nature. And by the way, there's a fantastic maintenance and reliability conference going on at the same time. Nick's going to be there. We're really excited. Some of Nick's bigger customers are there participating in it. And I hope you can come and see us there. And with that, I want to just tell you, I really view your attention and your time as a gift. Thank you. I accept it as such. And I hope that you got a couple of new ideas out of here. Even if you didn't get new ideas to do, if you got some new ideas about what to do to go study, to learn more about it, I hope we opened up an insight or two for you on this. And Nick, I really want to thank the MaintainX team for giving me the space to do this. Thank you. It's really great. I'm looking forward to expanding our partnership. We really have a lot of respect for what you're doing there in the world.
Thank you so much. It's the respect is mutual. We're thrilled to have you here, and I know you know what you're saying here is really, really valuable for the folks we work with to hear kind of this perspective. So it's been an absolute pleasure. A couple quick questions here, just from the audience here. I'll run through. We got one from Greg Christensen, another friend here of the team. And he wants to know, what's the biggest barrier to CMMS adoption, and what is the quickest way to break that barrier down for effective adoption? And how do you think about that from an Uptime Elements perspective?
I think a lot of it has to do with strategy. You may have a strategy to implement the technology, but you don't have a strategy to derive results from the technology. So those are two different things. You really need to make a distinction. Yes, of course, you need a good strategy to implement, the technology well. But then what are you going to use to drive why you have that technology to begin with? And I think a lot of that is disconnected. Yeah. I think a lot, when I talk to my brothers and sisters and cousins in the IT world, they do tell me, and Nick's company may be able to help verify this, that maintenance people tend to have a hard time describing what the business requirements are. It's really hard for software people to meet the business requirements when they don't know what they are, when you don't have an accurate picture of them. And I think a lot of maintenance departments don't really know what business they're in. And they don't really know what they're really trying to do. They're trying to, Nick, help me. I'm just trying to get through a day. Nick, Nick, everything's breaking down here. Help me. I'm sure he gets calls like that. And what he does, he slowly just sorts through and sifts through with the client. All right, let's settle down. Let's find out what the facts are here. And then he focuses his implementation as best he can on what he's perceiving as the customer's business requirements. But I would say, really learn how to write business requirements, because these software folks can do everything, anything and everything. And that's part of the problem. Because if we ask them to do that stuff without the business requirements, we don't even know why we got that custom change, and now we can't do the upgrades and all that kind of stuff. So I would say that's one. It's lacking the strategy, and it's lacking a formal maintenance business process. So what is your policy? Because if Nick sees your policy, he's going to understand it. If Nick sees your strategic maintenance management plan over 5 years, he's going to be able to stand right next to it and automate it. But the problem is only about 1 out of 100 of his customers has a 5-year written maintenance plan. So we have to act like better business people over on the maintenance side. I think we're great technically. I don't think there's anything better than maintenance people technically. I think they're absolutely fantastic. I think where we could all juice up is in the business side.
Yeah, that's a fantastic point. And I think that's something that we're still working with our clients on helping them kind of work through some of those frameworks, and then folks like yourself are here to kind of give them a very sort of different holistic perspective, which I think is fantastic. And another question here for someone who said, like, how do we make this resonate with their organization? And I know there's obviously some angles of they can kind of be that champion themselves, right? They can take this knowledge you've given them and go out and do that, be the change they wish to see. But there's also those that maybe they're not confident or ready enough to take that on themselves. Maybe they've got 300 other things, their hair's on fire. I know we talked about this conference here.
A couple of things I'd say about it. Listen, those guys have figured out how to. Those people have figured out how to get through a day.
Yeah,
it's tough for them, and they've seen different improvements come and go, and different software come and go, and different methods come and go, and centralize and decentralize, and all that kind of stuff. It's not the easiest business in the world, very misunderstood. And when you do it right, like I say, you kind of fade into the background a little bit. It's an area that we see companies make progress in when they sort of untangle the culture. And the culture is very tangled, but aligning everybody to go in the same direction. It's really, believe it or not, it's all the human things. And I'm a mechanic. That's where I started. I love people. I always have loved people, but I'm unusual for maintenance. I'm very talkative. I'm very communicative. I write a lot. I talk a lot. I like to present a lot. Most of the maintenance people are not quite like that. They're more the unsung heroes, the ones who really keep our world going. And a lot of them don't want the spotlight, and they don't necessarily work well with the rest of the company. And the rest of the company doesn't really understand or respect what maintenance is necessarily. So I just think it's a lot of the human side of things that we're missing. I don't know that we're missing a lot on the technology side, Nick. I think we're really missing a lot on the cultural and the people side of things.
That's a great point. And I guess sort of tangentially related to that, there's another question that came in. It says, how do I overcome that attitude of I don't want to see my maintenance techs in front of the computer or on their phones?
Oh, so terrible. Well, and by the way, I want to add one other thing to that second question.
Please do.
Ask, don't tell. Please do not leave this webinar and say, well, Terrence O'Hanlon says blah, 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 blah. Because those folks don't care what Terrence O'Hanlon says. They might have some interest, but not in that way. Ask them. Look at this reliability framework. what are we doing? Are we doing anything like this? Would you describe our program like this? What's missing from our program? What would you like to see our program do? Where do you think out of all these elements, where do you think one or two of them we could do right away without a whole lot of investment? What's one or two of them we should be doing in a year? What's one or two of them we should work out on a 3-year, and just listen. And if you don't want to do it with Uptime Elements, just ask, what is reliability to you? Ask your team, where does reliability come from? How are reliability decisions? Ask, learn the art of asking powerful questions. And I'm sorry, now I forgot the question I said I was going to go back to.
That's okay. It was just, how do we get people off? Like, how do you overcome that mindset of the maintenance technician should be on
being there? Well, by first off, by giving them the device to be with them. The asset, the system, and the technician should all be in the same place at the same time. That's one thing. And let them have an easy way to input it. I think eventually we're going to be going like this. Yeah, I replaced the seal on the mechanical pump and make sure purchasing orders a new one and blah, blah. And it's not even going to be a phone. It's going to be in our glasses or something, once we be able to talk to the computer. But in the meantime, I agree with whoever asked that question, because it ties into the earlier question. What are the key downfalls? Well, if your boss thinks that you're not being productive while you're standing at the computer, and that's the way you have to enter the information into your boss is way off. They who have the data is going to win. They who don't have the data is going to lose. You need the data to keep a safe, sustainable, reliable, and successful operation. There's just no two ways about it. You are the accounting department for the assets. You're that transactional department. I wish I could tell you there was an easier answer. Of course, technology companies like MaintainX are going to make it easier and easier and easier for us to input. The data is not going to be the issue. They're just going to keep making it easier and easier for us to add data. But it doesn't do any good just to add data. We need to add data in context and move it to knowledge. Your knowledge is currently sitting at the race is this. Your knowledge is sitting with all your 55-year-old maintenance people. And you got about 18 months to get everything that they know into MaintainX. How are we going to do that? And let's do another webinar about that. How do we take that asset knowledge from our very experienced people and then institutionalize it in technology? And we're right at the cusp. We're going to lose so much good technical asset knowledge in the next 5 years, 10 years. That's why I really appreciate what you're doing, Nick. You're becoming a repository for real knowledge to get people through a day in a safe way. And again, I got a lot of respect for that.
It's existentially important. I totally agree. I mean, we need to figure that out as a population of supporting this community. And I think this has been an incredibly valuable sort of presentation. I hope the folks watching appreciate the value and time that Terrence has shared with us here. I know we could probably go deeper for the rest of the day and the week on that, but unfortunately we gotta get going. So for those who want to, I do encourage you. I'm really glad if we were introducing you to Terrence for the first time to those watching. He's not a one-hit wonder. He's got a lot of great content. Please, look him up. He has a great wealth of knowledge on his website and online, but also he can come in and help work with your company directly if you reach out to him. So, and definitely come to this conference, IMC, in December. We'd love to see you all there. And if you have any other questions for us, please follow up with us after the webinar. We will make this recording available to you all. And Terrence, thank you very much. This was fantastic.
Thank you, MaintainX team. Thank you, audience. Really appreciate everything. Looking forward to presenting to you once again.
Fantastic. Take care, everyone.
Bye now.